Hey guys, welcome to the video for solving equations with variables on both sides. We're in Unit 1B and our essential question is what is the process for solving linear equations? So this is kind of the same thought process as solving one-step and two-step equations, except now instead of having a variable on just one side, now we have it on both. So our big goal is to always get the variable by itself, which means that there can be nothing in front of that variable. Not even a negative sign. We want the variable all by itself. Alright, so rule of thumb, I'm just going to try to keep my variables on the left. So anytime I see that there's variables on both sides, I'm going to try to move everything to the left side and everything that's not a variable to the right side. So the first thing I'm going to do is I'm going to go ahead and draw a line down my middle here. Okay, now off the bat, I notice that I have some variables and some numbers, and I want to move all the variables to the left side. However, that is not the only way to solve them. So there's many ways to solve equations, lots of ways. So in this first example, I'll go ahead and I'll move the variable first. However, if you want to move the constants, the numbers first, that also works. So I want all the variables on the left. I want them on this side, which means I need to move this x to the other side. And the way I'm going to do that is by subtracting 4x, because it's positive over there. And I subtract it from the 8x because the x's are like terms. I can't subtract it from 7. So these are going to cancel, and I have 7 minus 12x equals negative 17. Okay, next step, I want my x by itself, remember? So now I'm going to subtract 7 on both sides. Those cancel. I have negative 12x equals negative 24. Okay, last step here, I need my x by itself. Negative 12 and x are combined by the operation of multiplication, so I'm going to divide both sides by negative 12. And I've run out of some room, but I have x equals negative 24 divided by negative 12, which is positive 2. All right, moving on to number 2. I have a line down the middle because there's two ways, well actually there's 4 ways to solve these types of equations, but I'm going to show you 2 different ways. So the first way I'm going to show you is similar to the way we just did it, by moving the variable first. So let's go ahead and do that. We have 2y plus 14 equals 6y minus 10. I want to move all of my variables to the left side, which means this 6y on the right side has got to go, and I have to move it by subtracting. You can only move variables or move terms from side to side by subtracting or adding. So I'm going to subtract it from the 2y here. Those cancel. I have 2y minus 6y, that's going to give me negative 4y plus 14 equals negative 10. Okay? Again, I want my y by itself. You're always looking to see, I want that variable by itself. So now I'm going to subtract 14 on both sides. And I have negative 4y equals negative 24. Next step here is I'm going to divide by negative 4. So I have y equals positive 6. And how could I check this? Well, I could plug in 6 for anywhere I see a y in the original equation and see if the equation balances out. All right, now I'm going to show you a different way that I could do this problem. So 2y plus 14 equals 6y minus 10. So we're still going to go by the same rule. We're still going to want to move the variables all to the left, but this time, instead of moving my variables first, I'm going to get rid of my numbers first. So the first thing I'm going to do is I'm going to, well, since I know that I have to have all my y's on this side, I'm going to move 14 to the other side, which I'm allowed to do because it's, as long as I do the same thing to one side to the other, then everything is balanced. Okay, well, that goes away and I have 2y equals 6y minus 24. Okay, next step here. Well, I want all my variables on the left side, so now I can move my 6y to the left side by subtracting. So that cancels, and I have negative 4y equals negative 24. And my last step here is to divide both sides by negative 4. So then I have y equals, right, because negative 4 divided by negative 4 is 1. Negative 24 divided by negative 4 is positive 6. Let's see if it matches up what I got the other side. We got the exact same thing. So it doesn't matter how you solve equations as long as you do the same thing to both sides and as long as it's mathematically correct, right? Like I couldn't do like, oh, let me multiply everything by 7 because that doesn't really help us. So as long as everything is done from one side and you do it on the other side, then it should be balanced and you should get the same answer. There are many ways to get to the answer because everyone thinks a little bit differently. All right. So here I have 32p plus 60 equals negative 8p minus 120. All right, so I'll go ahead and revert back to the way that we've been doing it because maybe you're more comfortable with that, and that's okay. I'm going to move all of my variables to the left side, which means I need to add 8p to the other side as well. I'm adding because that 8p over there was negative, so these will go away, become 0. 32p plus 8p is 40p plus 60 equals negative 120. Do not forget about these negative signs. They do come along with it. It doesn't just go away. That's a mistake that we like to make that can cost us in the end. All right, now I'm going to subtract 60 on both sides because I want my p by itself. So I have 40p equals negative 180. All right, the next step here is to divide both sides by 40. Okay, well now I have p equals, and if I put that in the calculator, I'm going to get negative 4.5. So this one isn't a whole number, and your answer doesn't always have to be a whole number, right? Nothing in real life is always just a whole number, right? You go to the store, you buy stuff for $3.99. It's not going to say $4. So not everything is going to be perfect whole number all the time. So we do have to kind of get used to seeing, oh, hey, it's not always going to be super small and like cute and whole numbery. All right, moving on to the next page for number 4. We have something a little bit different. However, we still know how to do this. We've learned how to do this before. So I see there's parentheses this time, and I see parentheses on both sides of my equations. Well, I'm still going to do my math like I would normally, but in order to get rid of these parentheses, I'm going to have to distribute. So I'm going to do 2 times 4x. That gives me 8x. 2 times negative 5 gives me negative 10. And then I'm going to do 3 times 2x, which gives me 6x. And 3 times 8, which gives me 24. All right. Now I'm going to do what I've been doing. Get all my variables on the left, get all of my constants on the right. So I'm going to subtract 6x on both sides. So 8x minus 6x is 2x, and then I have minus 10. The 6x minus 6x cancels, and I just have positive 24. Now I'm going to, I need to pick a different color, purple. Now I'm going to move the 10 over, and in order to move it to the other side, I have to add 10 to both sides. That cancels, and I have 2x equals 34. My last step here is to divide both sides by 2, and then I have x equals 17, because 34 divided by 2 is 17. All right, moving on to number 5. We have 84 equals negative 2 plus 2 times 1 minus 6x. Now, here's the thing that's going to stump you. You're going to want to do negative 2 plus 2 first, which is incorrect. Because remember, PEMDAS says, well, I'm going to use my PEMDAS skills. So I need to distribute and get rid of those parentheses before I can do negative 2 plus 2. So I need to multiply. So I'm going to draw my line down the middle, where my equal sign is. And so everything is going to stay exactly the same, except now I'm going to have to do 2 times 1, which gives me plus 2, and 2 times negative 6x, which gives me negative 12x. Well, do I have any like terms? Yeah, I have some like terms. I have negative 2x, or negative 2 plus 2. What happens here? These cancel. So now I just have 84 equals negative 12x. Those terms canceled. So you always want to check for like terms. All right, Now I'm going to get my x by itself. I'm going to divide it by negative 12. Okay, well, negative 12 divided by negative 12 is 1. So I have x over that side. And then I have 84 divided by negative 12, which gives me negative 7. Now this one's a little bit different. Hopefully you've noticed that. Our x is on the right side. However, it means the same thing as x equals negative 7. So it doesn't matter, right? Like if I say I am 12 and 12 I am, I'm meaning the same thing. So it doesn't matter really the order, but if it's easier, just leave the x on the right side. You don't always have to move it to the left, but if we have the opportunity to move it, if I have two variables on each side, then just move it. But if I just have one variable, then just leave it on that side. Sorry, my box looks funky. All right, there we go. Number 6, negative 3 times negative 5p plus 8 equals negative 128 plus 13p. Well, I'm going to go ahead and draw a line down the middle of my equation. And then I'm going to do, I'm trying to find a color so it doesn't clash with the last one. Now we're going to get rid of those parentheses. We're going to do negative 3 times negative 5p, which gives us positive 15p. Negative 3 times 8, which is negative 24. Okay? And then everything on that side is just going to stay the same because I haven't simplified it at all yet. And now I'm going to go ahead and move all of my variables to the left side. So that means I'm going to get the variables that are on this side to move over there. Well, I only see one variable, and it's the 13p. So I'm going to move that to the other side, and I will subtract it from 15p. Okay? 15p minus 13p is 2p minus 24 equals negative 128. And 13p minus 13p is 0, so that goes away. Now I want to move all of my constant to the right side, so I'm going to add 24 to both sides. So I have 2p, and then negative 24 and plus 24 cancels. So I'm going to go ahead and move my 2p, it's kind of far away, 2p equals. And then negative 128 plus 24 is going to give me negative 104. And my last step here is I'm going to divide both sides by 2. And p equals negative 52. There we go. So p equals negative 52 here. That's our solution. All right, on the next 2 pages, we have some word problems. Now, I'm going to go ahead and go through these with you, and I'm going to go through it hopefully slow enough so that you understand it. But again, it's a YouTube video, so you can always rewind that. All right, so Sally's going to rent a car while she is out of town. One rental company offers a daily rate of $25 per day plus 5 cents per mile. Another rental company offers a daily rate of $20 per day but 7 cents per mile. At how many miles would the charges be equal? Okay, so we were given a lot of information here, so let's go ahead and look at the information that was given. Well, I know that one rental company offers a daily rate of $25 per day plus 5 cents a mile. Okay, so I know that one of the companies does that for me. Another company offers a daily rate of $20 per day and 7 cents per mile. So I'm given 2 companies, and I'm going to go ahead and just say green and pink. So I have a green company and I have a pink company. And I'm only saying green and pink is because I use those colors. So let's go ahead and create an expression for the green part. Well, I know it's $25 per day plus 5 cents per mile. Well, no matter what, every single day that I get that car, it's going to cost me $25. So if we're just talking about for one day, at how many miles would the charges be equal for one day? Okay, so I know for one day I'm going to get charged $25, and that's flat. Like, no matter what, I will get charged $25 at minimum. And then it says plus, I'll also get charged 5 cents per mile. But I don't know how many miles I can go, so that's the thing that we don't know. So X is going to be my number of miles because I don't know how many miles I'm going. Okay, well, if I don't know how many miles I'm going, but I do know how much I'm charged, I'm going to put 0.05x. Now, the $25 and the 0.05x, I'm going to add those 2 things because it's going to give me my total for how much it's going to cost to rent from that company. Now, you can put 0.05, but I just put 0.05 because I don't want to have to write another 0. Okay, and then the other company Actually, let me get rid of these equal signs. The other company charges $20 per day, but 7 cents per mile. Well, I know for a fact that it's going to be $20 for that day. So it's going to be $20 flat for that day. And then it says 7 cents per mile. So I don't know how many miles I'm going, but I know for every single mile, it's going to tack on 7 more cents, 7 more cents. So I'm going to add 0.07 to this one. Okay, so now I have my two expressions. And then it asks, when will they be equal? So if I'm asking for when they will be equal, I want to know when green is going to equal the pink company, which means I'm going to set them equal to each other. Okay, and now I solve. Okay, well now I'm going to go ahead and draw my line down the middle, and I'm going to continue with my math like normal. Well, I want all of my variables on the left side. So I'm going to go ahead and I'm going to subtract 0.07x over here to cancel it, and I'll also subtract 0.07x on this this left side. So then I have 25 minus 0.02x, because 0.05 minus 0.07 is 0.02, a negative 0.02. And then I have equals 20, and then the 7 cents over there cancels. Okay, the next step here is to move all of my constants to the other side. So I'm going to subtract 25 on both sides. So I have negative 0.02x equals 20 minus 25, which is negative 5. And now I want to get x by itself, so now I have to divide, right? Negative 0.02 is being multiplied to x. So the inverse of that would be to divide by negative 0.02 and divide the other side by negative 0.02. Okay, well, on the left side, these are going to cancel, and then I have x equals, and if you do negative 5 divided by negative 0.02, you should get 250. Okay, well, what does that mean? What does x equals 250 mean? Well, that means that you need to drive, or she needs to drive, well, remember, x, I said at the beginning, means our number of miles. So the question asks, how many miles will the charges be equal? Well, the 250 means that she would need to drive 250 miles for them to be equal. All right, so let's move on to plan B. So we're adding on some extra information here. She plans to rent the car for 5 days. How many miles would she need to drive them to be equal? All right, so I'm going to go ahead and copy what I had at the beginning. So 25 plus 0.05x equals 20 plus 0.07x. Okay, now the extra information here is it's saying for 5 days. Well, how much am I getting charged each day for the green company? If I look back here where I highlighted green, it says a daily rate of $25 per day. So for 1 day, I'm getting charged, so let me back up. For number 1, we're looking, and we know for what we calculated that this is for 1 day. So let me make that a little neater, a little bit more legible. Okay, this information is just for 1 day. Well, now it wants to know if I have the car for 5 days. So if I have the car for 5 days, if it's $25 per day, then I need to multiply that by 5 in order to get how many days. So really I have a D here. So we have an extra variable in our equation. However, I know that my D, which stands for days, the number of days, I know I want it for 5 days. So I'm going to substitute in a 5 there. So I have 25 times 5, because I have it for 5 days, plus 0.05x equals 20 times 5, because it's 5 days, plus 0.07x. So right now I have this information, and let's go ahead and simplify. Well, 25 times 5 is going to give me 125, and then I still have the plus 0.05x equals, and then 20 times 5 is 100 plus 0.07x. So the miles for the green company, I'm still getting charged 5 cents a mile over here. But instead of $25, it's going to charge me $125 because I've asked for 5 days. Same thing with the pink company. I have $20 a day and 7 cents per mile still, but since I'm going for 5 days, I now have $100 that I'm going to be charged. All right, from here, again, you would solve like you would earlier. You're going to go ahead and move all of your variables to the left side. So I'm going to subtract, I'm going to subtract 0.07x from both sides. And so I have 125. Oops, I forgot to draw a little line here. I'm going to go ahead and draw a line. I'll do that in a different color. Let's do purple. Okay. So I have negative 0.02x on here equals 100 because it's 0.07 minus 0.07 cancels. And then I'm going to move all of my constants to the left side. So I have minus 125, that cancels. And then I have minus 125. Well, that's going to give me negative 0.02x equals negative 25. Well, how do I get the x by itself? I'm going to divide both sides by negative 0.02, divided by negative 0.02. Negative 0.02 divided by negative 0.02 cancels. And I get x equals 1250. Now what does this mean? It means if I'm driving for 5 days, they would be equal once I get to 1,250 miles. All right, moving on to the second word problem. A triangle with equal sides and a perimeter have the same, and a square have the same perimeters. Let me reread that. A triangle with equal sides and a square have the same perimeters. The length of one side of the triangle is x plus 1. The length of one side of the square is 2x plus 6. 2x plus 6. What is the value of x? So I'm going to go ahead and I'm going to draw a picture. I know that I have a triangle, and I know that I have a square. Well, what do I know about the triangle? Well, it says that the triangle has equal sides. So every single side of my triangle is going to be the same length. I also know that the length of one side of the triangle is x plus 1. So that means this side of the triangle is going to be x plus 1, this side of the triangle is x plus 1, and this side of the triangle is x plus 1. So they're all x plus 1. For my square, well, what I know about squares, squares have the same side length on every side. And I also know that one side of the square is 2x plus 6. So I'm going to do 2x plus 6, which means this is also 2x plus 6. And this is 2x plus 6. And this is 2x plus 6. Okay, I have my pictures drawn. And I also know that they have the same perimeters. Perimeters mean I'm going to add up all of the sides and get the total. So for the triangle, let's go ahead and add up all of our sides. Well, let's look at our like terms here. I have x plus x plus x. So let me show you what I'm talking about. X plus x plus x. That's going to give me 3x. And then I have let's use pink. I have 1 plus 1 plus 1, which gives me plus 3. Okay. Well, over here, I'm going to go ahead and combine my like terms. I'm going to add 2x plus 2x. That's going to give me 4x, plus 2 more x, which gives me 6x, plus 2 more x, which gives me 8x. And then I have 6 plus 6, which gives me 12, plus 6 more, which gives me 18, plus 6 more, which gives me 24. So the perimeter of my square is 8x plus 24, and the perimeter of my triangle is 3x plus 3. But I know that they have the same perimeters. So the perimeter of that one and the perimeter of that one are going to equal. So if they have the same perimeters, they're going to equal each other. So I have 3x plus 3 equals 8x plus 24. And it says, what is the value of x? So I'm going to solve for x, and I'm going to get all of my variables, again, on the left side. So I'm going to begin, and I'm going to subtract 8x on both sides. So 8x minus 8x over there will cancel. And if I do 3x minus 8x, that's going to give me negative 5x plus 3 equals 24, which is what I have left over there. And then my next step would be to move all my constants to the right side. So I'm going to subtract 3 on both sides. So those 3's will cancel. I have negative 5x equals 21. What color haven't I used yet? Baby blue. And then I will divide both sides by negative 5 to get that x by itself. And I have x equals, I believe it's some decimal. Yeah, let me check. Let me put it in my phone. 21 minus 5, or not 21 minus 5, 21 divided by negative 5 is going to be negative 4.2. So the value of my x is negative 4.2. All right. All right, so that was it for our word problem. This one was a little bit more easier to understand, I think, because we were able to draw a picture. And then the last one was a little bit like, whoa, there's a lot of things going on. But again, if you have any questions, please feel free to always ask and let me know if you have a question.